7.4 in big ideas. So these are properties of special parallelograms. We've been talking about parallelograms and all the different things that we get with that. Our lesson objective today is going to be very simple. I want you to be able to use properties, so students will be able to use properties of special parallelograms, and then we're going to talk about what they are. Okay? First, we're going to start with rhombus, then we'll do rectangle and square. And I'm quite certain that you're all familiar with these because, you know, you've been growing up with these particular shapes. However, we're going to define them a special way. They're all parallelograms, which means both opposite sides are parallel. However, a rhombus specifically is a parallelogram with 4 congruent sides. And as you can see, here are the markings. Okay. I always think of a rhombus as a squished square because it's, you know, sort of slanted. Now, in a rectangle, it is also a parallelogram. But as you can see, it has different markings. It has 1, 2, 3, 4 right angles. Definition. And then, so this is 4 congruent sides, this is 4 right angles. A square is both of them, right? It's got both these and those, and these are my favorite. This is the hardest to prove. So it's a parallelogram with 4 congruent sides and 4 right angles. Okay, so basically, if you want to prove something's a square, you have to show it's a rhombus and a rectangle. We have some corollaries, and the corollaries are based on the definition. Let me take this off of my clipboard. And it's a corollary because this is just saying what it is. But this says that a quadrilateral, just a quadrilateral, is a rhombus if and only if, remember we can abbreviate it like that, it has 4 congruent sides. So if you don't know that it's a parallelogram, you have to prove it's a parallelogram, okay? But we know for sure if it has 4 congruent sides, it is a rhombus. If it's a rhombus, it has 4 congruent sides. 1, 2, 3, 4. Rectangle corollary is exactly the same process where we're going to say it's a quadrilateral. Quadrilateral is a rectangle if and only if it has 4 right angles. So if it has 4 right angles, then this quadrilateral is a rectangle. Again, saying nothing about parallelogram, but they are special. And then the square corollary is also based on this definition. So quadrilateral is a square if and only if it is both, excuse me, a rhombus and a rectangle. It has to meet both of those definitions before it is. And this is a handy little picture in your notes. Keep this. It's a Venn diagram. And this Venn diagram shows that this whole big box is all parallelograms. But then there's some special ones, right? I mean, we did those in sections 1, 2, and 3. But the special ones are rhombuses, where they have the 4 congruent sides, and also rectangles, where they have 4 right angles. The only object that has all of those properties are squares, and that's why they're in this Venn diagram in the middle. So just as a reminder, they're all special parallelograms, so they have all these figures. They are special figures, so they have all these properties. Remember, as parallelograms, their opposite sides are congruent. as parallelograms. Their opposite angles are congruent. We also know that their consecutive angles are supplementary. Number 4, we know that their diagonals, hopefully you remember this from section 3, bisect each other. And then last, they also have that property that their opposite sides, obviously, are parallel. So they have all these if they're in this box. I'm going to add that to your notes. Again, I'm going to go a little bit more quickly, so I'm going to turn this over so we can continue on these. There's a particular type of problem I want to go over with you, and it's always, sometimes, never. That Big Ideas is going to throw at you. Now, you're given a rhombus, QRST, and you have to decide if these statements are always true, sometimes true, or never true. All you really have to do is find an example. If you can find even one example where it's not always true, then you know it's sometimes. If you can't find any examples where it's always true, then it's never. So this is the hardest one to consider, but what we're going to do is simply draw a diagram. Okay, remember the order of the vertices in the name, and I'm just going to draw a parallelogram. QRST means they have to be in order. Okay, and you could do it QRST, that's fine too, just as long as they all follow each other. So when you're looking at angle Q and angle S, I want to know, I've got a rhombus. Is it always, sometimes, or never true that this angle is congruent to that angle? So ask yourself, what's the definition of a rhombus? The definition is that it's a parallelogram with 4 congruent sides. Because it's a parallelogram, this will always be true. Always. Okay, I hope that makes sense to you. Because all parallelograms have opposite angles that are true. Now, got another picture here. So Q, R, S, T in order. Is it true that angle Q is always congruent to angle R? I can tell you right now it's not always, because I just drew a picture where it's not always. But it's also not never. There is one situation where it is. Can somebody tell me what situation would be where they would be equal? Yeah. And if they're both 90 degrees, then you can say when it's a rectangle or a square. Exactly right. So sometimes it does work, but not always. And those problems are in the problem set. Another one here. We're just going to look at this. If I give you this picture, what kind of special quadrilateral is it? Rhombus, rectangle, square. Obviously it's not a square because this is not 90. But because this is not 90, it's also not a rectangle. The only one left is a rhombus. Can we classify that as a rhombus? Yes? Since it says to explain. And all we have to do really is just say that all sides are congruent. We're not going to go over that part. We're going to start with our theorems, and we have 3 theorems. Now that you've got your definitions down, here they are. First of all, rhombus diagonals are beautiful things. A parallelogram is a rhombus if and only if its diagonals are perpendicular. This always happens. So what you have is AC perpendicular to BD. It doesn't mean they're bisected like the last theorem, but you do know that if this happens, they are perpendicular. Now, there is a proof here. I'm not going to go over it right now because, like I said, I already made a video with other examples, and I want to make sure that we have plenty of time during class to get going through these. So just remember, parallelogram is a rhombus if the diagonals are perpendicular, and that means if your diagonals are perpendicular, then that also means that you have a parallelogram that is a rhombus, both ways. So second page, we're going to go on to here. Okay. Now we have one very similar, but we're going to look at the opposite angles. So parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So this is really handy, actually. This means that A and C are both bisected into these angles. They're all four the same. But then also B and D are also bisected. So we've got the double markings. So really, if you know one of these angles, you can figure out quite a bit more. So we're going to use that one doing some problems. I'm not going to do this proof at the moment. We'll probably do it tomorrow. But right now, we're going to go straight to the problem. Okay? The problem says, find the measures of the numbered angles. So it's telling us it's a rhombus, which means we know that AC is bisecting angle A and angle C. We know BD is bisecting angle B and angle D. So it's asking us to find angle 1, angle 2, angle 3, and angle 4. And there's a lot of different ways we can do this, but let's put measure of angle 1 here, measure of angle 2 here, measure of angle 3 here, and measure of angle 4. Okay? First of all, this one is marked 61 degrees. That's not going to help me figure out angle 1. But I do know that it's a rhombus. So what is the degree measurement of angle 1 from that first theorem we did? We know it's perpendicular, so perpendicular is 90 degrees. Okay. Now we're looking for angle 2, and again, I'm going to look at my 61. Does 61 help me figure out number 2? Obviously, yes, because it says it's a rhombus, which means it's a parallelogram. If AB is parallel to CD, by the definition, then 61 and 2 are alternate interior angles. So this is going to be 61 degrees by alternate interior angles theorem. Now we're going to move on to number 3. Again, I know it's a rhombus. 2 and 3 are the same because, as we know, it's bisected. So that means angle 3 is also by the diagonals bisect angles. I'll just write it that way. And then last is number 4. This is the only one that's a little tricky, okay? Because 61 doesn't help us here. 2 and 3 doesn't help us. 1, no. So really what you have to do is look at what is 4? Well, it's totally separate. I don't have any help here. So what I'm going to do is look at it like this. This triangle right here is a right triangle. We know that the measure of angle 1 is 90 degrees. That means that 3 and 4 have to be complementary. Or you could just say that the triangle sum theorem, we know what 3 is. 3 is 61. We know 1 is 90. And we know that all 3 of those have to add up to 180. So number 4 is going to be 29 degrees. And that's by the triangle sum theorem. Okay. All this is coming together. We have a lot of stuff. Now in this same picture, if I did ask you to identify ADC, that's ADC, I just figured out that angle 4 is 29. It's a rhombus, so this is bisected. So this is going to be twice as much as 29, right? This is going to be 58 because it's twice as much. Also, if I want to know BCD, it's going to be twice as much as 61 because, again, it's bisected. So 2 times 61 will be 122 degrees. See how that comes out? Hope everybody is good with that. We're getting to the end here. And luckily what I wanted to do right here is the rectangle diagonals theorem. So far we've done rhombus. We've done 3 different ways to show that something's a rhombus. So now we're going to move on to rectangle. We have 2 of them. A parallelogram is a rectangle if and only if its diagonals are congruent. And the nice thing about this theorem is that it looks like it is, right? From A to C is the same distance as from B to D. It also happens to be a parallelogram, so we know that it is bisected. Okay, so if you can show that those are congruent, then you have the rectangle diagonals theorem. Any questions? So what I have to do now is turn the page. There's not going to be a proof on here, but we are going to use this to do a problem. Okay, so we'll do that proof tomorrow. The problem here is that I've got QRST, and it's telling me that QS is 5x minus 31, and RT is 2x plus 11. So if you want to find those lengths, and you know they're congruent because of the theorem we just went over, just pull out your algebra skills and set them equal to each other. Ta-da! I'm going to take away 2x from both sides. I'm going to add 31 to both sides. So 31 plus 11. Is that 42? Yeah. And then I'm going to divide both sides by 3, where x is 14. Now it says find the lengths of the diagonal. I still haven't finished that. So I'm going to take 14, I'm going to plug it back into either one of these. They should be the same. Personally, I'm going to choose this one because of the plus and the smaller numbers. I always like to make things easier for myself. So then this is going to be 2 times 14 plus 11. So that'll be 28 plus 11. And I think that's 39 degrees. But it's not, sorry, it's not a degree, it's a measurement. So 39 is equal to QS, and that's also equal to RT. Do a little box on there. Again, if you have a question, you can unmute yourself, or you can pop your hand up, because I have a second screen going on and I can actually see your hand in the chat window. Otherwise, I'm going to try to keep going because we have a little bit more. All right. One of the things we're doing in this chapter, you'll notice, is that we're doing coordinate axes. So if you have something like this, we're not doing this entire problem because there's like 8 different steps. But I am going to tell you what the steps are. So for right now, if you want to know whether it's a rectangle, a rhombus, or a square, okay, first you just look at the definition. So if you want to find that it's any one of these, all 3 of these are special parallelograms. Note, you are not given that it's a parallelogram. So the first thing you have to do is you have to show it's a parallelogram. You cannot meet any of those definitions without showing it's a parallelogram. If you don't remember how to do that, remember, you show that the midpoints are the same. Midpoints of diagonals are the same. We've done that in the previous days a few times, so you do that first. Then second, okay, once you know that they're parallelograms, if you want to show that they're a rhombus, well, you could show that all four sides are congruent, but that takes the distance formula, and that's a little annoying, as you know, because square roots and all that. Instead, what you can use is that theorem, and you can just show that your diagonals are perpendicular. And that's by slope. Remember, if you show that both of them, if you find the slope of this diagonal and this diagonal, and they multiply to give you a product of -1, that's what you're looking for the definition of perpendicular, then it's a rhombus. If you want to show that it is a rectangle, well, again, you'd have to prove by definition that you have 4 right angles. But that's a lot of work. There's another way to do it. We have a theorem that says that the rectangle, it's right above on a parallelogram is a rectangle if and only if the diagonals are congruent. So if you want to show it's a rectangle, show that the diagonals are congruent. Now it's actually not that bad because when you go like this, right, you actually have a right triangle if it's a rectangle. So you can use the Pythagorean theorem. That's just a squared plus b squared equals c squared. So that's much easier. So show it's parallelogram, show it's a rhombus, show it's a rectangle or not. And then last, because a square is both of those, really all you have to do to show it's a square is you have to show it's both. So if you do show it's a rhombus and you show it's a rectangle, then you can just say it's a square. You don't have to do anything separately. But that's a lot of work. And like I said, there's an example in the other video. So we're going to just go on to the next page. It is fairly straightforward, if nothing else. Now what I've done, this is going to be handy for you, is that a lot of what this is about is how to prove that a quadrilateral is one of those special parallelograms like that Venn diagram. Okay, so I broke it down into like a little cheat sheet sort of. Remember, one important reminder, if you're not given that it is a parallelogram, first you have to show that. Okay, and if you recall, you'll have to do slopes and show that those opposite sides have the same slope. So we have a number of ways. So first of all, we have 3 ways to show something is a rhombus. These are 3 theorems. We have 2 ways to show something is a rectangle, 2 theorems. And then last, you need to show, if it's a square, that it's both a rhombus and a rectangle. So let's run through these quickly. If you want to show all 4 sides are congruent, then you use the distance formula. If they're equal, then they're congruent. Okay, they have an equal measurement. If you want to show that the diagonals are perpendicular like that theorem, then what you have to do is find the slopes of the diagonals. Okay? If the product of those 2 slopes is -1, then you get perpendicular. Okay, because that's that definition. Third way to show a rhombus is to show the bisecting the angles. However, we really can't show that. So we're just going to put a big X through that one. And then rectangle, if you want to show that all four have right angles, then what you have to do is you have to do the slopes, because you have to show perpendicular. So you have to do the slopes of all sides. And again, just like the rhombus, if product, and you have to do the product of all four corners. Okay. Because that shows right angles. So you have to do all four. If you want to show a rectangle this way, to show that the diagonals are congruent, well, then again, you're going to have to use the distance formula on both of the diagonals. On both. If they're equal, then you get congruent. And then last, but not least, if you want to show it's a square, then you have to show it's a rhombus and a rectangle. It's got to meet both definitions. But basically, you have to pick one of these three methods to show it's a rhombus. And then you have to pick one of these two to show it's a rectangle. You have to do both. You can't skip any on that. Okay? But that's it. That's all. Okay? Those are the end of our notes for today. You should be able to take these notes directly and go straight to big ideas. Again, if you want more examples, watch the other video as well. And then I'm going to be posting this one along with it for my absentees.